Hi, my name is SYAHMI bin Muhammad SHUKUR, and I would like to demo my mini project that called Hotel Lexus multi-level parking. And here we got a HMI interface. This is my main interface. I got a start button to run the program, stop button to stop the program. Trend is for to acquire the data. You can see the data will come in here with the value. So we got alarm, and alarm will appear here every time the process of this program is running. And here we can select the car that we're going to be choose, and this is the slot of the car that will be entered here. And this is the enter button for confirmation. So for the second floor, we got a sedan car. First floor, we got a SUV. Ground floor, we got a 4x4 car. And here will be the indicator where the car slot parking is full. And here is the counter to tell us how many cars have been entered in this floor. And all this counter can be look at the trend here. And also we have also a AZIZ interface where after the car has entry here, we can also choose the car, which car will be exit. Then I will demo. First we will start the program. So the green light will turn on and indicate that the program will be running. So before that, I would like to show the factory IO of my program that will be help me run this HMI. Here is our factory IO program. So here with the sedan car will be entry. Here will be the SUV car, and here will be the 4x4 car. And each car will be go to turntable. And will be entry here. So the entry here is entry into the building. Here the elevator that will bring the car to each floor. So the ground floor is for the 4x4 car. The second floor is for SUV car. And the second floor is for sedan car, and the pusher here will work as a mechanism to put in the car or the box for factory IO in the parking. So after that, the car also will be exit using this elevator and will exit here. So we will demo now. So I will choose a sedan car for second floor, and we choose a second slot car, and then we press enter. So that car is going here. The car now in the second floor will be entering the second slot of the parking. So now we will choose SUV. We will choose as first slot. Here we see the SUV car is entering and go to the table. Then that's why we choose a 4x4, and then we choose a third slot of the car. In the alarm here, we can see the process of the car is being entering the building. Car is entering the lift, so the ground floor conveyor is running. So it showed every process that is happening in the building. So the trend here will show the value of how many cars have been entering the building. So we got one count for sedan, one count for SUV, and one count for, sorry, the 4x4 count is a little bit slow. Yeah, see, the count has go rise up 1, so the exit is still 0. So now I will full the slot for sedan car to trigger the alarm for telling the car is full. So for the third slot of sedan, I will show the car entering by the factory I/O, so we can see the whole process on how the car is entering the building. So here, the car will be entering here, and the table here it was used to sort on if the different car is entering from different area. So the car is entering the building, and then you go to second floor, see if it's a sedan car. So now car is in the conveyor of the second floor. I will be pushing to the slot of the third parting. And lastly, we will choose the fourth slot to make the car park full. So when the sedan parking floor is full, the alarm will pop up and tell us. So first we need to acknowledge the parking. So the right light will turn on. So what we're going to do is we go to the exit floor, and we will bring out one of the car in the of a sedan floor to make a room for another slot. So I will choose the middle one. The light indicator in the entry will be disappear. Now for an exiting car, I will show the factory I/O, the whole process. So we pick the sedan floor for the first slot. So the car will be pushed up, and the elevator will go up, and then after that the conveyor will be there are two things that need to be take note, that each elevator can only must be used for one purpose only. So the entry elevator can only go to one floor, and the exit elevator can only go to another floor that is not for entry elevator. So let's say the entry elevator go to second floor, the exit elevator cannot go to the second floor. It must go to another floor until the whole process is end. So I will put this for the entry. I will put the SUV car in the second slot and enter the car, and the exit elevator can go to the other floor and exit the car, as long it's not at the in the same floor. So the exit elevator will go to the second floor, and the entry elevator will go to the first floor. Both of these elevators cannot go to the same floor because the conveyor will be interrupted. in the factory IO, when we put the car in the slot, we use the green light in the button to indicate that the process of the car being entering is run. Same with the exit. We exiting the car. With green light will indicate that the car is still exiting. So after the car is entering, the green light will be displayed. Also same with the car when exiting, the green light will be disappeared. On the trend, now show the value of the car that have been entering. Sedan is 4, the SUV is 2, 4x4 is 2, and the car exit is 3. When press the stop button, the counter will be disappear, will be reset. But the car is still in the parking. This is my program block for network 1. This is the system they're going to start the program and stop the program. For the network 2, this is the sedan entry car, sedan car entry. So this is the sedan car 1 button for factory IO. This is the HMI assembly IO field where we can choose the car type. 1 is equal to sedan, and car slot is 1 for equal to slot 1. For this is the sedan car slot 1 IoT. So this is slot number 2, the slot number 3, and this is the slot for number 4. We also have a IoT button and button for factory IO. So when the sedan car entry, the turntable will be turned on. So the sedan entry sensor detecting the car, the turntable will be turned on. So the sedan car will be going to the second floor. So when the sedan any slot car, the green light in the factory IO is turned on, the car will be go to the second floor. So next, when the car is going to enter the parking, I use the function chart to make the program look more organized. So example, say this the slot parking sedan car second floor slot number 1. So the pusher the sensor for the car will be push into the parking, will be detecting the car, and the pusher will be turned on and push the car into the slot. So this is the parking number 2 for the second floor, the parking number 3 and parking number 4. All the coding is the same, but it's the different slot of the parking. So for the SUV also same like the sedan. You have the button for factory IO, and the car type will be number 2, means that the number 2 is equal to SUV type. So this is slot number 1, and this is the IoT button for this car. So this is the slot SUV car slot number 2, SUV car slot number 3, SUV car slot number 4. So when the SUV car is entering the program, the turntable will be turned on. This is SUV entry sensor. So the turntable will be turned on and helping the SUV car entering the building. So the SUV car will be going to this first floor. So the any SUV from the slot 1 until 4 will be entering the first floor. So first floor parking 5 is equal to SUV car slot 1. For parking 5, 6, 7, 8 is the slot 1 until 4. So SUV car like 1 will the sensor for the parking slot will be detecting the car and will push the car into the slot. So all the fuzzy chart is the same program, but it's a different slot and different slot and it's a different sensor. So for the 4x4 car, the 4x4 car 1 is the button for factory I/O, and the car type 3 is 3 and is equal to 4x4 car type, and this is the slot number 1. So the 4x4 1 IoT is for the IoT button. So we got the slot number 2, slot number 3, and slot number 4. So when the 4x4 car is entering the building, the turntable for 4x4 car will be turned on for the factory I/O. So 4x4 entry sensor will be turned on the turntable. You also have a timer here. So the 4x4 car will be going to the ground floor. So 4x4 car light car 1 until 4 will be going to the ground floor. So ground floor parking 9 is equal to ground 4x4 car 1, parking 9, parking 10, parking 11, parking 12 is 4x4 car 1 until 4. So inside of this function chart, it's the 4x4 car light 1, and it's a same program as before, but it's a different sensor for different parking slot. For exiting the car, is we also use the exit the function chart, and the function chart we also have a button for, let's say example, exit sedan car 1, the factory I/O button. So this is the car type. So for sedan we use a 1. This is car slot number 1, and this is the IoT button. So the car will be pushed out from the parking. Push out from the parking and exit the car. So this is for exit number 1 until number 12. The program is the same, it's just a different sensor and different pusher. So after the car is being pushed out, this is the sequence for each floor of the car. So let's say the sedan car has been pushed out for the car exit. The exit second floor will be turned on for the sedan car. So here exit sedan car light 1 is as example. So parking 1 sensor. So when the car is being pushed out, the exit second floor will be turned on. This is for the first floor. When the exit SUV car is turned on, and also the sensor of that parking slot to turn on, this first floor sequence will be running to retrieve the car. It's also the same as the ground floor. The ground floor is for the 4x4 car. So exit 4x4 car will be trigger this sequence, and also the parking slot sensor will be trigger this sequence. This is the network for countering. So this is the counter for sedan car that entering, so SUV car that entering, 4x4 car that entering, and this is the counter for car that exit. This is the network for displaying the counter in the factory I/O using the move. This is the network for indicating if the parking is full. That we could also use this sedan full, SUV full, forever full in the alarm program. And the alarm program uses the function chart because there's a lot of alarm that we'll be going to use. And this is the network for leaf movement in the HMI. to make the lift move by triggering the sensor in the HMI.
Our parking system also have IoT function that we already create on the node rack. As you can see, this is the dashboard display on the node rack. There are start and stop push button to start or stop the operation. To enter the car in the parking slot, click any type and number you want, then scroll down below and click confirm to enter the car in the parking slot. Same goes to the exit car from the parking slot. Click any existing car on the parking slot, then scroll down below and click confirm exit to exit the car from the parking slot.